Equation px square minus 7x plus 6 whole 0 has two distinct roots, alpha and beta. Also, alpha is equal to 4 by 3 beta. Find the value of p. Find the value of p. Okay. See, the equation this has two distinct roots. So, two distinct roots. I have already told you na about when you are having two distinct roots, then you are this. See, from what we were having in quadratic equation, we were having this. Okay, I will share you this. To show you a type of question where you can easily solve it. Wait a minute. Okay, if you just remember, do you remember the quadratic equation, Sophia?
Yes, ma'am.
Okay, so in quadratic equation, we have seen the discriminant and the nature of the roots. You remember that? B square minus 4ac. Okay, so when we have two distinct roots, as it is said in your question, we have two distinct roots, alpha and beta. So what is given there? If you are having two distinct roots, if you are having two distinct roots, then what is the condition? It is b square minus 4ac is greater than 0.
Yes.
Okay, so here if you take out b square minus 4ac, so your alpha may be okay, alpha and beta. Wait, alpha is equal to 4 by 3 beta. Or you can do it. Have I taught you in this type polymer? Wait, if I'm teaching polymer. Okay, you have done the relationship between zeros now. From there, easily you can do it, Sophia. See, sum of zeros will be what? Sum of zeros means alpha plus beta will be what? Sophia? Alpha plus
b minus b by a.
Yes, minus b by 8 will be, and product of zeros will be c by 8. Yes. Okay. So if you are going to add the zeros here, alpha plus 4 by 3 beta. Okay. So this will be the sum of the zeros because these are the two roots, and it is given that alpha is equal to 4 by 3 beta. So if you are going to add alpha plus 4 by wait, just I will write it and show you. Okay.
Should I stop sharing it?
Wait. I'll just note down the main things here. Px square minus 7x plus 0. Now you can stop sharing. Okay. I'll share my screen. You stop sharing, then only I'll be able to. So here only I'm explaining you. Okay, it's a probability section, but I will explain you here. Okay. Polynomial. Okay. So your equation is what? Px square minus 7x. Am I right? Just check it. Px square minus 7x plus 6 is equal to 0. Okay. And alpha is equal to 4 by 3 beta. And here alpha and beta are zeros. Yes. So we know that sum of zeros. Sum of zeros, that is alpha plus beta is equal to minus b by a. Okay, if you're going to put this in alpha plus 4 by 3 beta is equal to minus, what is the value of b? It is again minus 7, and value of b by a will be p. Okay, understood, Sophia? So it will be, if you're going to take the LCM, so 3 alpha plus 4 beta is equal to 21p. Okay, so which implies that p is equal to so it will be 21 by okay. And one more thing we have, that product of 0 alpha into beta is equal to c by a, which implies that alpha into 4 by 3 beta. Wait a minute, what I'm doing. Alpha value is given, na 4 by 3 beta. So here you have to write 4 by 3 beta, here you will write beta. Okay. Okay, so when you're taking LCM, so it will become 7 beta, and here when 3 will come, 7. So P will be equal to 7 beta. Okay, so here implies P is equal to 3 upon beta. Okay, now from here what you will get? Okay, alpha value will be 4 by 3, 4 by 3 beta multiplied by beta. Okay, which will be equal to c by a. C value is what in the equation? 6 by p. Okay, 6 by P. Okay, so that will imply we are going to multiply beta. So it will be 4 by 3 beta square. Okay, is equal to 6 by P. Okay, which imply that P is equal to 6 by 3 by 4 beta square. Okay. P is equal to beta square. So we have got P is equal to 3 by beta and 9 by 2 beta square. Okay. अगर बीटा की वैल्यू यहाँ से निकाल लो, इस इक्वेशन से बीटा की वैल्यू आप निकाल सकते हो सफिया, क्योंकि हमें P की वैल्यू निकालनी, बीटा की नहीं निकालनी. ओके, सो बीटा वैल्यू विल बी इक्वल टू व्हाट? 3 by P. Yes, correct. Beta value will be 3 by P. Okay. So now you keep the beta value here. So it will be P is equal to 9 by 2. What was beta value? 3 by P. 3 by P square. Okay. Which will be equal to P is equal to 9 upon 2 multiplied by 9 upon P square. Okay. Now this P square will come above. Am I right? So P is equal to 9 multiplied by P square upon 2 into 9. This 9 will be cancelled. And then P will also be get cancelled here. Okay. So P will be 1 is equal to P. What you can do here, P square upon P is equal to 2. Okay. So which will give you P is equal to 2. Is your answer 2, Safia? P? Safia, what's your answer? Means where you have got the question, you have got the answer also there? Or this is a question from the exam?
No, I don't have the answer.
Okay. So have you understood the process?
Yes, ma'am. Like we have to make 3 equations and then we have to solve it.
Here you have got the zeros. Okay. The main thing is that you already know the zeros and alpha and beta. And we know two relations between alpha and beta, that is the sum of the zeros and the product of the zeros. Okay. The sum of the zero is equal to B minus B by A, and the product of the zero is C by A. Okay, so alpha plus beta. So here in alpha, you will see alpha value is given as 4 by 3 beta. Okay, and beta is as same as beta because two zeros are alpha and beta, and alpha is in with the relation of beta, but the relation alpha beta के बीच में that is given. Okay, or either you can write, if you want, you can write it as 3 alpha is equal to 4 beta, but that doesn't make any sense. Okay, because here we have to put the alpha, direct alpha value. Okay, so alpha is equal to 4 by 3 beta. Okay, understood? Now, instead of alpha, wherever you are solving, instead of alpha, you are going to write 4 by 3 beta. And in place of beta, only beta will be there. So now we have formed first equation here, that beta is equal to 3 by P. Okay, we have got the value of beta, that is 3 by P. And from here, the product of alpha plus beta, we have got C by A. Okay, so when on solving, we'll get P is equal to, here we have got, here we have got P is equal to 9 by 2 beta square. Okay, so instead of beta, we are going to write the beta value. Okay, that is this beta value. Okay, so when you are going to place the beta value, then we have got the value of P is equal to 2. Okay, now any doubt is there? Sophia, still any doubt is there?
Yeah.
Okay, try to do this question once more. Okay, and if you think that doubt is there, you can ask again. Okay. Okay, now different types of problems based on a single event. Okay, so we have in the last class, I think we have already seen the problem based on tossing a coin. Okay, so I'll just quickly revise it when we are tossing, because these all problem you will get in your class 11th also and class 10th also. The probabilities are very main chapter, and how much simple it is now, it will become little tricky when you go in 12th. Okay, so problem based on tossing a coin. When you're tossing a coin, everybody know when we are tossing a unbiased coin or a fair coin, then we have two outcomes, okay, of this event. Okay, that is, one is the head, one is the tail whenever we are tossing a coin. Okay, so the sample space will contain H and T. Okay, but when we are tossing a single coin, then the sample space will contain H and T. But if we are tossing two coins simultaneously, then in both the coins, only head can come, only tail can come. In one of the coin, head can come, in other tail. Okay, so we have 4 sample space here: HH, HT, TH, and TT. Okay, now similarly, when we are tossing 3 coins, okay, so here the sample space will have 8 values. Okay, all the 3 okay, so in the first condition, when we are having all the heads, okay, on all the 3 coins, head has come. Okay, one condition will be there, in all the 3 coins we get the tails. Okay, and one condition when first coin only have the head and other 2 coins can have head and tail. Okay, so there will be 2. H, HT, and HTH. Okay. So similarly, we'll be in the sample space, we'll be having 8 values, 8 outcomes. Okay. And accordingly, we are going to solve the problem. Okay. Understood? We have seen this problem yesterday. Okay. Now, one thing to remember, the term that you will see, and from now on, whenever you'll get the probability question, you will see these terms. Okay. At least and at most. Okay. And in permutation combination, I think there also it is there. At least and at most. Okay. So what is this at least and at most? At least means come say come. Minimum value should be this, and maximum wherever you till where you can go. Okay. That in fact, for example, if I'm telling you at least one head. Okay, I'm tossing 3 coins simultaneously. So the sample space will be having 8 values. Yes or no, Sophia? It will be having 8 values. And I'm telling you to find the probability of an event of at least one head. At least one head means minimum of one head. So when I'm telling you at least one head, so what will be the condition here? At least one head. Okay, so just we are going to check the sample space. At least one head means minimum of one head will be there. HTH, okay, there are the outcomes here. I'm not written here outcomes. Okay, for 3 heads. So HTH will be one of the outcomes. Yes. Just a minute. Yeah, at least one head. No, here I have taken 2 heads. No, for 2 I will go afterwards. First take one head only. Okay. So at least one head means from minimum of one head we will start. Okay. So minimum of one head when we are going to get in 3 conditions. THT and THT, HTT and TTH. Okay. When we are getting only one head. Okay. Understood? Now it is written at least one head. मतलब कम से कम one head होना चाहिए. That means you will be including those values also, those outcomes also, where you are getting 2 heads. Okay, so when you are getting 2 heads, HHT and HTH. Okay, understood? And one more will be there, THH. Okay, understood? Now at least one head. So one head can be there, 2 head can be there, and the maximum of here in this condition we can get 3 head. So 3 head will also be included here. Okay, understood? Only we have left TTT. Okay, because I have written at least one head. So this is the sample space of at least one head. Okay, these are the outcomes, you can say not sample, these are the outcomes of the one head event. Okay, at least one head. Now if I say at least, I'm writing different pen using to distinguish. At least 2 head. So if I'm writing at least 2 head, that minimum of 2 head should be there. Okay, so it will be HHT. Okay, and HTH and CHH. Okay, and HH. HH will be there. Okay, so have you understood this concept of at least and at most? And this was of at least. At most means maximum of that value. Okay, if I'm writing at most 3 head should be there, means maximum 3 head. Minimum you will take 1 also and 2 also. Okay, if I'm writing at most 2 head should be there, so 1 will also be included and 2 heads will also be included, 3 heads will not be included. At most 1 head, only one single head will be included, and here null heads will also be included. Null head means none of the coin has shown heads. Okay, that will also be included. Okay, because maximum of 1 head is set. Okay, now let's see some more example here. Okay, so we are having one more example here. 3 unbiased coins are tossed together. Find the probability of getting. Okay, now let's see this question. Now 3 unbiased coins are tossed together. Find the probability of getting all heads. Okay, so first of all we should write all the sample space. Okay, that what are the possible sample space of this event. Okay, so sample space, if I'm writing, so what will be the sample space here? All the 3 will be having head, and then all the 3 can have tail. Okay, and then 2 of them will be having head. Okay, and then 2 of them will be having tail. Sorry, it will not be there. This I have already written. What is this? Okay. HTT. Okay. So these are the sample space. Now possible outcome, if you say total possible outcome, if you see, so there are 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, if you see the first one, all head. Okay. If I'm saying all heads, so all heads means here the sample space, I'm writing the E1. Sample space will contain what? All heads will have only one outcome here. So the probability of E1 will be, probability is what? Probability means number of outcomes of favorable event, okay, upon total numbers of possible outcome. So here the favorable event E1 is given as 1. Okay. Here even you can see here only one in sample space, only one value is there. So 1, and the favorable outcomes here are, sorry, possible outcomes are 8. Okay. So here the probability we have got 1 upon 8. Okay. Now similarly, if you see here, the second one, 2 heads. Okay. So in 2 heads, if I'm representing as E2, so you can see here 2 heads means, okay, so here E2 value can be 3. Okay. E2 means the number of favorable outcomes. Okay. Number of favorable outcomes can be 3. So P E2, the probability of getting 2 heads. Okay. The probability of getting 2 heads will be 3 by 8. Okay. Understood? Safiya, any doubt in this probability? Understood this?
Yes.
Okay. Now third, if you see the third one, one head. Okay. So only single head will be there. So here, if you see the probability of E3, what it will be? Can you tell me, Safiya, what will be having in the sample space of E3? Single head should be there. So in his single head, we'll be having 3 values, I think, TTH and THL. Yes. So probability of E3 will be again 3 by 8. Okay. Now similarly, we'll be doing for 4. Now let's check what is the fourth condition. At least 2 heads. Okay. Now you can see here at least 2 heads. Okay. So maximum of, at least 2 heads means minimum of 2 heads should be there. So here E4 will be containing HL, at least 2 heads, HTH. So here probability of E4 will be equal to 4 upon 8. That will be 1 upon 2. Okay. Got it? Any doubt in the question, Satya? Okay. Now, what is the second type of problem that we can get in probability? Okay. There will be so many problems that you will be getting in your probability, but these are some of the common problems that you will be seeing in your probability question. Okay. One was a coin, when we will be having cards, then from a pack of bag, you have to find out bag, balls or marbles or something. Okay. We'll see one by one. Okay. Each of the problems. Okay. Now, the second type is problem based on throwing a dice. Okay. So when you're throwing a dice has 6 faces. Okay. A dice has 6 faces. Now, what are the 6 faces? Represent 1, 2, 3, 4. There are 6 numbers on these 6 faces. Okay. So when you are throwing a dice, there in the sample space, you will be having 6 possible outcomes. That is 1, 2, 3, 4, 5, 6. Okay. So this is the sample space of a single die. Okay. Now, when you're throwing 2 dice, so it is possible that on the first dice you are getting 1, and in the second dice you can get any other number 1, 2, 3, 4, 5, 6. Okay. So you can see here I created a sample space of 2 dice. When you are throwing 2 dice simultaneously, एक साथ जब आप 2 dice throw करते हो, so what will be the favorable outcomes? Okay, so it will be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Similarly, for till 6, all the 6 values. Okay, for both the you can say for both the dice, you'll be having this. So the total number of, okay, so the favorable outcome will be 36. Okay, now let's see example here. Okay, let me copy the example and then I will explain. Now, you can see here a dice is tossed once. Okay, now if you see only single dice is tossed here, so that means if the single dice is tossed here, so what will be the possible outcome here, Safiya? The possible outcome will be 6. Okay, so what are they? Sample space will contain 1, 2, 3, 4, 5, 6. Okay, the sample space will contain 1, 2, 3, 4, 5, and 6. Okay, so now the total number of possible outcome we have seen 6. Now we'll go for the first condition. Okay, so first one, what does the first one say? A number 4. Only it is talking about a number 4. So a number 4 can come one time. Okay, from the sample space it can come one time. So if you see E1, the event of getting a number, okay, number 4, what will be that? E1 is equal to, in sample space you'll be having 1, that is 1 value. Okay, so what will be the probability of getting E1? It will be E1 upon S. Okay, so what it will be? 1 upon 6. Understood? Any doubt in this, Sophia? Now, similarly, we are going to see for all other sections only. One second. A number greater than 4. So if you see a number greater than 4, then in the sample space we'll be having in this event of getting a number greater than 4, we'll be having how many numbers? 5 and 6. Only 5 and 6 is greater. So in the second one, you will be having E2. In this sample space will be 5 and 6. That will be 2 only. So PE2 will be equal to 2 by 6. That will be 1 by 3. Okay. Understood? Now we'll see the third one. What is the third one? A number less than, now similarly a number less than 4. How many numbers are less than 4? From the coin, if you see, from the dice you will see 1, 2, 3. Okay, these numbers are less than 4. So if you find out the probability of PE3 event, so it will be 3 by 6. So it will be 1 by 2. An even number. So even numbers, what are the even numbers that we can see on a dice? That is 2, 4 and 6. So again PE4 will be equal to 3 upon 6, that is 1 by 2. Fifth is what? A number greater than 6. Now, if you see a number greater than this condition, I have already told you. Can you tell me, Safiya, a number greater than 6 will be what? A number greater than 6.
That will be 0.
Yes. And which type of event it is?
Impossible.
Yes, very good. This is an impossible event because we're not having this value only. Okay, so it will be 0. Okay, understood? Any doubt till here in the dice? We'll see one more question in the dice and then we'll move to the third section. Okay. When is your mathematics exam, Safiya?
It's tomorrow.
When?
It's tomorrow.
Tomorrow only you are having exams. Okay. So best of luck for your exam. Okay. Now, question number 6. 2 dice are thrown simultaneously. Find the probability of getting an even number on one dice and a multiple of 3 on the other dice. Okay. Now you see, we are throwing 2 dice. So what will be the sample space? You'll be having 36 outcomes. Okay. The sample space you can see here, I have already built. Okay. Now we'll be having 36 possible outcomes. But what will be the outcomes of this particular event of getting an even number on the one dice? Okay, on the first dice or any one of the dice, you'll be getting an even number, and on the other dice, it should be a multiple of 3 on the other dice. Now, what are the even numbers? Even numbers you will be getting as 2, 4, and 6. Okay, you can see here I have mentioned here. Even numbers will be 2, 4, and 6. And the multiple of 3 will be, what will be the multiple of 3 according to the sample space? It will be 3 and 6. Okay, multiple of 3 will be 3 and 6. That means the combination will be among these 2 values only. 2, 2, 3. Okay, it will be 2, 3, 2, 6. Okay, it will be 2, 3, 2, 6. And then you'll be having 4, 3, 4, 6, 6, 3, and 6, 6. Okay. And similarly, you just reverse it because it is not said that first dice should have this value. Okay, it is just telling you. So you can have the combination here 2, 3, 2, 6. Okay, and then 3, 2, 6, 2. Okay, similarly, you will be having 4, 3, 4, 6, 3, 4, 6, 4. Okay, and the next number will be 6, 3, 6, 4, and then you will be having 3, 6, and 4, 6. Okay, so these will be the process. So how many you are having? I'm not missing anyone.
Did you say something?
No. 6, 3. Okay, now you can see this one is common. 6, 4 and 6, 4. So we'll be eliminating from one of this. Okay, now here also 4, 6, 4, 6. So these values should not be there. Okay, I have just written all the possible and then I'm going to. Okay, rest are all distinct. Okay, so how many values we are having? Okay, here I have erased that. 2, 3, 2, 6. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we are having 10. I have written here 11. How come? 2, 3, 4, 3, 6, 3, 2, 6, 4, 6, 6, 6. Yes. 3, 2, 3, 4, 2, 6. Yeah, 11 will be there. I missed something over. Okay, so here it will be all the values. You will make the combination of the values. Okay. Then we are having number of outcomes. Okay, number of outcomes is the condition will be 11. So probability will be what? PE will be what? 11 are your favorable outcomes and 36 is your sample space. Okay, that is the possible outcome. So this is your probability of getting the probability of the event of getting even number on one dice and a multiple of 3 on the other dice. Okay. Now type 3 problem based on playing cards. Now here it is not visible, okay, maybe in notes in your PDF it will be visible, okay, because this is of black color, that's why it is not visible. Okay, I will make this actually these two symbols are with the black color, okay, that's why it is not visible. Okay? These two symbols are with the black color, that's why it's not visible. Okay, Safia, do you know about cards?
Yes, ma'am.
Okay, so do we know how many cards are there in total? How many cards we have?
In total, there are 52.
Yes, so the total there are 52 cards, and this 52 cards are divided into 4 suits. Okay, now the pack of every suits contain 13 cards. Okay, every suits contain 13 cards. Now, what are these name of the suits? Okay, 13 cards of heart is there. Okay, 13 cards of diamond is there. And the black card consists of 13 cards of spades. Now you can see a chart here. Okay, refer to this chart. Okay, the total of 52 cards is there. Among that 52 cards, 26 cards of red are there, 26 cards of black are there. And in red also you have heart and diamond. Okay, heart and diamond is there. Okay, and in black you are having club and spade. Okay, the shapes are mentioned here. Heart. Okay, wait, I will use another pen. Okay, so heart is there, diamond is there, spades is there, and club is there, and all the cards are 13 in your number. Okay, so they jointly make 52 pack of cards. Okay, not 52 cards in a pack. Okay, and the fourth section, these are called what? Club. Okay, sorry, suits. And they are class suits, and each one is called the. Now here, if you say 13 cards, ये समझ में आ गया आपको ये chart. Now among these 13 cards of heart or diamond or club or spades, what are there? We have in 13 cards, you will be having ace. इक्का जिसे कहते हैं in Hindi, ace. Then you will have 2. Instead of 1, we are having ace, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, and then the rest 3 cards, you will be having a joker, queen, and a king. And these 3 cards are called the face card also. Okay, we call it face card also. Okay, so we are in total we are having 12 face cards in a pack of whole 52 cards. Okay, see, I have mentioned here all these. Okay, all 32 cards. In 32 cards, you having cards of suit. You are having ace, king, queen, jack. 10, 9, jack or joker. Some people say jack, some say joker. Okay, 2 and 3. Now, how many face cards are there? There are 12 face cards. King, queen, and jack are included in that. So total. Okay. Now let's see the questions. Okay. Now remember the names: heart, diamond, club, and your spade. Okay, because these names will be mentioned in your questions. Okay. We'll see one example today, and after that we'll see tomorrow. Okay. Now a card is drawn from a well shuffled pack of 52 playing cards. Okay. Find the probability that the card drawn is. Now it is 52 cards are there. Now it is asking you what find the probability that the card drawn is a diamond. Okay. So card drawn is a diamond. How can you tell the card drawn is diamond? What will be the probability of getting a diamond? So 13 cards of diamond will be there in a pack of shuffled in a pack of cards. Okay, in the pack of 52 cards, 13 cards are there of diamond. Okay, so what will be the probability? It will be 13 by 52. Okay, now similarly, an ace or a queen. Now the second one is ace or a queen. So ace can be of any of the 4 you can say suits. Okay, it may be of a diamond or spade or club. Okay, or jack. Okay, so you'll be having how many? Ace will be 4. Okay, 4 ace will be there, and 4 your queen will be there. Okay, so there will be total of 8. Okay, so the possible favorable outcomes will be, so not possible, favorable outcome will be 8, and your possible outcomes will be 52, because there are 52 cards in a pack. Okay, 52 cards in a pack. So that will be 8 by 52. Okay, 8 by 52. Understood, Safia?
Yes, ma'am.
Okay, now jack of heart. Now see, jack of heart. So we are just talking about jack of heart. Sif heart ka jack. If it is written of red, jack of red color, okay, then there will be 2 jacks, but it is just specifying only of heart. So only single card will be there. Okay, jack of heart, are only single jack is there of heart. Okay, so 1 by 52 cards. Okay, now the rest of the question we'll see in the next class. Okay, and the question that you asked on probability, just do that questions one more time. Okay, if you have doubt, you can message me. Okay, and if you have doubt in the probability section also, you can message me, because I think it's not completed. Okay, some of the questions are still remaining. So you'll be able to do questions based on cards, Sophia? if you're doing question on card, you have to remember the favorable outcome will be 52. Okay, so there are total of 52 cards, and 52 cards are divided into red and black color. In red, you are having diamond and heart, and in black, you are having spade and club. Okay, understood? And the face card, there are 3 face carded, so total of 12 face card are there. Jack, king, and queen. Okay, and in turn, in 10 numbers, you are having ace 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 is represented as ace for a card, whatever you say. Okay, so any doubt till here, Sophia?
No problem.
Okay, so we are ending the class here only. Okay, and we'll see you on Sunday. Okay, bye bye.